Hey, what's up? We're going to learn about angles outside of circles today. But before we do that, I want to do a quick run back, because it's been a while, of what happens when we have angles on the inside of circles. So we're talking about angle and arc measure, how many degrees they are. So there's a couple different type of angles we focused on. The first is a central angle, because the vertex is at the center of the circle. Good name. And this angle, 90 degrees, is going to be the exact same as the arc measure on the outside. They're the exact same. So if this would no longer be a right angle, and I made it 92 degrees, that means this arc that it intercepts on the outside would also be 92 degrees. Okay, they're going to be the exact same thing. The other thing we talked about were called inscribed angles. When the central angle, we have the vertex in the center. An inscribed angle, we have the vertex that is somewhere on the circle. So this is an inscribed angle. The angle's in the circle and the vertex is right on the circle. Now this angle, we'll say this is a nice 100-degree arc out here. This angle is obviously not 100 degrees because it's an acute angle there. But it works out nicely. It's actually just half. So that means this will be a 50-degree angle there. So those are our two types. Central angle, the exact same as the arc measure, and inscribed angle, which is going to be half of the arc measure. We need to be able to go from here to here and from here to here. We have to be able to solve both. Okay, so that's just a quick rundown of what we did a while ago. But today we're going to look at what happens when the angle's on the outside, like this one. This angle's on the outside. Okay, and this is our first scenario. We'll look at all three real quick here, then we'll kind of give a sum up of the whole strategy, okay? This is a secant, because it intersects twice. A secant intersects twice. So we have two secants. Okay, they intercept two arcs. There's a big arc, and then there's a small arc. Okay, so the angle hits a small arc and then a big arc. So that's when you have two secants. Okay, let's look at this next scenario. In this scenario, we have one secant. Here's our secant. And we have one tangent. So one secant, one tangent. But what I want you to notice here is that there's an angle on the outside, but there's still first a small arc that you hit, and then a big arc that goes from the tangent around to the second part of the secant. Okay, so we still have a big arc and a small arc that's formed. Okay, so we did two secants. We looked at one tangent and one secant. So that leaves us with the last one here, which is two tangents. Okay, HO is a tangent and HT is a tangent. But what I want you to notice here is that we still have our two arcs. We have the angle and then intercepts a small arc, which would be arc OT, and then a big arc, which is OFT, all the way around there. So we still have a big arc and a small arc. So we don't have to memorize all three of these. We can have one formula that's going to help us with all three, and we don't have to memorize individual things. Okay, our angle on the outside is going to be the big arc, sorry, not a line, big arc minus your small arc divided by 2. Big arc minus small arc divided by 2. That's going to be your outside angle here. If you need to pause this and write that formula down, that's going to be something that you'll want to have in front of you. Okay, let's head down here real quick and look at an example problem. Okay, so here's an instance where we have two secants, right? We have one secant, two secants. Now we're not looking for the angle, we actually already have that, but that's okay, we still use the same formula. The angle equals big arc minus small arc divided by 2. The angle, 62, equals the big arc, 141, minus the small arc, which is this is where our x is, divided by 2. Now we don't necessarily love that divided by 2 there, so we multiply to get rid of it, times 2 on both sides, so we have 124 equals 141 minus x. Now this can be a little bit of an uncomfortable algebra equation for some people. Don't be scared of negative numbers. We're going to subtract 141 from both sides. That'll leave us with negative x equals a negative 17, which means that positive x here would have to equal positive 17 degrees because it's an arc measure, which is in degrees. Okay, on example 2, we have a tangent and a secant. Okay, same thing though, the angle, 55, equals big arc minus small arc divided by 2. The big arc, 6x, minus small arc, 40, divided by 2. Again, we don't like that divided by 2, so we get it out of there. Multiply by 2 on both sides. We have 110 equals 6x minus 40. And this is a pretty comfortable algebra equation for us to work with. Add 40 to both sides. We've got 150 equals 6x. Now we divide both sides by 6 and we'll have our answer. Of 25. And there's a couple things I want to look at here. With two tangents, there's a couple of different scenarios. And I actually want to do this B one here first. Or I guess it's C. The key thing with these tangents to realize is that there are still 360 degrees in a circle. So if we want to figure out what y is, we could just take 360 minus 152. That means this is 208 degrees for y. Once you have that set up, now we can go big arc minus small arc divided by 2 to get our angle. So 208 big arc minus 152 small arc divided by 2 would equal our angle, which is x. So on this one, I actually want to subtract that. 208 minus 152, which is 56, divided by 2 equals x. So 28 degrees is the measure of that angle. Okay, so that's a big key when you're doing these tangents, is to realize that together they have to add up to be 360. Now this example A up here at the top here, this is about as tricky as they can make it. But we'll kind of look at how we can get through that. Okay, because they didn't give us either of these, they just gave us the angle. So if we do the angle, 68 equals big arc y minus small arc x divided by 2, it's like, how can we do that? We have two variables. Again, the key when we have two tangents is to realize it's 360 degrees all the way around. So what we can do is say, well, if this was 60, you know that y was 300, right? Because you do 300 minus 60. If this was 100, you'd know that this was 260. 360 minus 100 is 260. So we want to use that thought process to say, that's not going to be y. That's just going to be 360 minus whatever x is. Okay, so when we do that and rewrite this as 68 equals, instead of y, I'm going to put 360 minus x minus the small arc, so then minus x divided by 2, and now we're going to be able to solve this thing. Okay, multiply both sides by 2. We got 136 equals 360 minus x minus x. That's silly to put minus x, right? We have minus 2x's. So 360 minus 2x. Again, this is going to be an uncomfortable math situation because we're going to have to work with negatives. We're going to drop 360 on both sides. You're left with a negative 2x. And 136 minus 360, we've got negative 224 equals negative 2x. Divide both sides by negative 2. X is 112 degrees. Now we don't have to go through this whole mess again to find y, because y is just 360 minus x. Sorry about that. So we're going to do 360 minus 112 to find out what y is. So y is 248 degrees for this bigger arc. Okay. And then just to quickly finish up here, we're going to go over there and look at example B. This is just a good reminder. We're talking about tangents with a circle. When you have a tangent to a circle and another tangent to the circle that starts on the other side, those lengths are always, always, always going to be